Your scanner shows P0420, and the estimate says catalytic converter. The car may still drive normally, and the converter may truly be worn out. But P0420 is the result of a catalyst efficiency monitor. It is not a report explaining why that monitor failed. An exhaust leak can affect the sensor readings. A misfire, fuel control problem, oil consumption, or coolant leak can damage the converter. Replacing the converter without finding the cause can bring the same code back. Before approving an expensive repair, make these 5 checks. First, do not clear the code. Check 1. Preserve the evidence. Before removing a sensor or crawling under the vehicle, save the information already stored in the computer. Record every trouble code, including codes that appear unrelated to the converter. Pay close attention to misfire codes, fuel trim codes, oxygen sensor codes, coolant temperature codes, and exhaust-related faults. P0420 applies to bank 1. On an inline engine, there is normally only one bank. On a V-shaped engine, bank 1 is the side that contains cylinder number 1. Do not guess which side that is. Use service information for the exact engine before buying any bank-specific component. Next, save the freeze frame data. Freeze frame is a snapshot of the conditions present when the computer recorded the fault. Depending on the vehicle, it may include engine speed, coolant temperature, vehicle speed, engine load, and fuel trims. That information can reveal whether the monitor failed during highway driving, low-speed cruising, high load, or another specific condition. Also, check the catalyst monitor readiness status. A ready monitor means the vehicle completed the test. A not ready monitor means the test has not completed since the computer was reset, the battery was disconnected, or the codes were cleared. Clearing the code can erase freeze frame information and reset the emissions monitors. That may remove the clue showing when the fault occurred. It can also delay an emissions inspection because the vehicle must complete the required driving conditions again. Before paying for a repair, search the exact year, make, model, engine, and code for technical service bulletins or manufacturer campaigns. Some vehicle-specific P0420 problems have involved revised diagnostic procedures, software updates, or extended coverage. Also, check the vehicle's emissions warranty. In the United States, the original catalytic converter is generally included among the major emissions components covered for 8 years or 80,000 miles, whichever comes first. Coverage depends on the vehicle, the cause of failure, and the manufacturer's claim procedure. Check that before authorizing the repair. Once the evidence is protected, inspect the part of the system that can change what both oxygen sensors see. Check 2. Look for exhaust leaks. The catalyst monitor depends on the exhaust stream reaching the sensors in a predictable condition. Outside air entering through a leak can make that information unreliable. Begin with the exhaust completely cool. Never touch a hot manifold, pipe, oxygen sensor, or catalytic converter. Start the engine outdoors and listen during the first cold start. A small manifold or gasket leak may create a sharp ticking sound. That sound may become quieter as the exhaust heats up and the metal expands. Look for black soot around the exhaust manifold gasket, flanges, welds, flexible pipe, and oxygen sensor mounting areas. A crack or leak close to an oxygen sensor is usually more relevant to P0420 than surface rust near the rear muffler. Do not assume every leak will be loud. A small leak may open only when the engine moves under load. It may also be hidden above a heat shield or behind another component. A professional smoke test or controlled low-pressure test can locate a leak that is difficult to see. Do not block the tailpipe with your hand. Do not run the engine inside a closed garage. And do not spray flammable chemicals onto a hot exhaust while searching for a leak. If a leak is confirmed, repair it first. Then allow the vehicle to rerun the catalyst monitor under the required conditions. If the exhaust is sealed and P0420 returns, the next question becomes more important. What has the engine been sending into the converter? Check 3. Check the engine before the converter. A catalytic converter processes the gases produced by the engine. It cannot protect itself from a continuing combustion problem. Start with misfires. Check for P0300 and cylinder-specific codes such as P0301 through P0308. Do not look only at current codes. Some scan tools can display misfire counters or history even when the engine appears to idle normally. A weak ignition coil, worn spark plug, injector problem, compression fault, or contaminated fuel can create an intermittent misfire. When unburned fuel and oxygen enter the converter, the chemical reaction can generate extreme heat. That heat can melt or damage the internal catalyst material. Next, look at fuel control. Large positive fuel trims may point toward extra air entering the engine, weak fuel delivery, or inaccurate airflow information. Large negative fuel trims may indicate that the computer is removing fuel from a mixture it sees as too rich. The exact acceptable range varies by vehicle and operating condition. The important question is whether the engine is controlling the mixture correctly when the catalyst monitor runs. Then consider oil consumption. An engine that burns oil can contaminate the converter over time. Look for a falling oil level, blue-gray exhaust smoke, oily spark plugs, or a documented oil consumption problem. Coolant consumption matters as well. A slow internal coolant leak may contaminate the converter even when there is no obvious puddle under the car. Watch for unexplained coolant loss, repeated overheating, white exhaust vapor that continues after the engine is fully warm, or other evidence that requires proper diagnosis. Do not assume the converter is healthy simply because you found a misfire, rich condition, or oil problem. Both faults may exist at the same time. The converter may already be damaged. Repairing the engine protects the replacement and allows the catalyst monitor to be evaluated under valid conditions. Imagine installing a new converter on an engine that still misfires under acceleration. The new part may clear the code temporarily, but every hard acceleration sends the same damaging exhaust into it. The converter can be the failed part, while the engine remains the root cause. Once the engine condition is under control, inspect the components many people replace first: the oxygen sensors. Check 4. Verify the oxygen sensor data. Most gasoline vehicles use a sensor before the converter and another sensor after it. The upstream sensor, or air-fuel ratio sensor on some vehicles, helps the computer control the mixture. The downstream sensor helps the computer evaluate what happens after the exhaust passes through the catalyst. That does not mean the rear sensor should be replaced whenever P0420 appears. A sensor can report bad news without causing the bad news. Begin by checking for oxygen sensor or heater circuit codes. Inspect the wiring near the exhaust for melted insulation, damaged connectors, loose terminals, corrosion, or poor previous repairs. The wiring operates close to heat, water, road debris, and vibration. A signal that is not reliable cannot be used to judge the converter confidently. Next, identify which sensor type the vehicle uses. A conventional narrowband oxygen sensor does not produce the same data as a wideband air-fuel ratio sensor. Do not apply one universal voltage rule to every vehicle. Use the correct data parameter and the manufacturer's test procedure. When graphing sensor data, the engine and converter must be fully warmed. The vehicle must also be operating under conditions where the catalyst monitor can evaluate the system. On many applications, a healthy converter reduces the rapid oxygen changes seen before the converter. The downstream signal, therefore, behaves differently from the upstream signal. If the rear signal follows the upstream activity too closely under valid test conditions, reduced catalyst oxygen storage capacity becomes more suspicious. But that pattern is supporting evidence. It is not universal proof. Sensor design, scan tool update speed, engine condition, exhaust leaks, and the vehicle's monitoring strategy all affect what the graph looks like. A rear sensor that is stuck, slow, biased, or electrically faulty requires circuit diagnosis. A rear sensor that responds normally and reports poor catalyst behavior should not be replaced simply because it costs less than the converter. If the exhaust is sealed, the engine is operating correctly, and the sensor information is trustworthy, the catalytic converter moves much higher on the suspect list. Check 5. Confirm catalyst performance. P0420 is an efficiency code. It does not automatically mean the converter is clogged. Those are different failure conditions. A converter may allow exhaust to flow normally, but no longer store oxygen or process emissions well enough to pass the monitor. The vehicle may drive normally while the check engine light remains on. A restricted converter is different. It may cause poor acceleration, limited engine speed, excessive exhaust, back pressure, unusual heat, or a loss of power that becomes worse under load. A physically damaged converter may rattle because the internal material is broken. A converter damaged by a severe misfire may contain a melted substrate. A contaminated converter may lose efficiency without creating an obvious restriction. Professional confirmation depends on the vehicle and the equipment available. It may include the manufacturer's catalyst monitor procedure, a controlled comparison of upstream and downstream sensor behavior, an oxygen storage test, a calibrated emissions analysis, or a back pressure test when restriction symptoms are present. Do not use exhaust temperature alone as proof. Temperature changes depend on engine load, mixture, converter location, airflow, and test conditions. A temperature difference may support a diagnosis, but it should not be the only reason a converter is replaced. The same applies to catalytic converter cleaner. A chemical cannot repair melted catalyst material, broken internal parts, a cracked housing, or contamination caused by continuing oil or coolant consumption. If the code disappears temporarily, that still does not explain why the monitor failed. When the engine is healthy, the exhaust is sealed, the sensors and circuits test correctly, and the catalyst repeatedly fails the manufacturer's valid performance test, replacement becomes justified. At that point, use a converter approved for the exact vehicle and local emissions requirements. A converter with the wrong application, insufficient catalyst material, poor fit, or incorrect sensor placement can create another fault even when the engine is healthy. Repair, replace, or keep testing. Here is the complete diagnostic order. If P0420 appears with misfire, fuel control, temperature, or sensor codes, diagnose those faults first. If there is an exhaust leak, repair it and confirm that the leak is gone. If the engine is burning oil, losing coolant, misfiring, or operating too rich or too lean, repair that condition before installing a converter. If the oxygen sensor signal or circuit is unreliable, diagnose the sensor system. If all of those areas test correctly and the catalyst repeatedly performs below the vehicle's threshold, the converter becomes the most likely repair. Before approving replacement, ask the shop these questions. What other codes were stored? What did the freeze frame data show? Was the exhaust checked for leaks? Were misfires and fuel trims evaluated? Is the engine consuming oil or coolant? Were the oxygen sensor signals and circuits tested? What test confirmed low catalyst efficiency? And what will prevent the replacement converter from failing for the same reason? Clear answers indicate a diagnosis. The code says catalytic converter is only the beginning. Also, ask whether the converter is still covered by an emissions warranty or manufacturer campaign. That check should happen before you pay for the repair. Can you keep driving? A steady check engine light with P0420 does not always mean the vehicle will stop running immediately, but the code should not be ignored. The vehicle may fail an emissions inspection. The converter may also be the result of another engine problem that is still active. Limit unnecessary driving and arrange a proper diagnosis. Stop driving and have the vehicle inspected immediately if the check engine light is flashing, the engine is misfiring severely, power drops suddenly, the exhaust system becomes unusually hot, you smell burning material, or the vehicle begins overheating. A severe misfire can send unburned fuel into the converter and create damaging heat. Do not park over dry grass or other combustible material if the converter may be overheating. Do not remove the converter, replace it with a straight pipe, or use a spacer or electronic device to hide the monitor result. The correct repair restores the emissions system and fixes the condition that caused the failure. P0420 may lead to a catalytic converter replacement, but the code alone does not explain why the monitor failed. Save the evidence. Check for exhaust leaks. Confirm that the engine is not misfiring, burning oil, losing coolant, or operating with a fuel control problem. Verify the oxygen sensor data. Then confirm catalyst performance using the correct procedure. That order protects you from replacing a good component. It also protects a new converter from the problem that damaged the old one. Do not guess which part the car needs. Use the code, the data, and the test results to prove the repair. Subscribe for practical car care guides that help you diagnose the problem before you start buying parts. Next, watch the guide on P0171 and why a lean code does not automatically mean the oxygen sensor is bad.